Today we are covering gas optimization for your ROAS smart contract. Gas is a cost of computation, and cheaper contracts mean happier users and more efficient transactions. We will use 4 simple tricks to cut the cost. Let's start now. First, choosing the right structure is the biggest gas saver. Standard ROAS containers are built for RAM, not blockchain storage. NEAR Collections are optimized to save gas by only fetching the specific data you need from persistent storage. Let's check use case and recommended NEAR collections. For simple key value lookups, for example user balances, contract settings, we'll use LookupMap. Only allows one specific entry. The gas cost is constant time. The gas consumption does not grow with the number of records in the map. For set of unique items, whitelisted, tracking unique voters, we'll use LookupMap set, optimized for past membership checks. Contains constant time performance similar to LookupMap. Mostly append order list, its token IDs, event logs, we'll use vector. Optimized for adding to the end and retrieving by index. It only loads one element at a time when accessed. This is recommended choice for persistent lists, even small ones. Alternative for small order data, we'll use Vec. ROAS native collections are simple to use but load the entire collection into memory on every read or write. Use only when the list is guaranteed to be tiny. And paginated data. For this we will use iterable map, allows fetching a range of keys which helps front-end application avoid costly full contract scans. Every transaction submitted to NEAR has a basic gas fee just for being proceed. If you perform 10 small actions over 10 transactions, you pay that base fee 10 times. The solution is batching. The insert item batch function allows the user to add a single item. If a user needs to add 10 items, they must send 10 separate expensive transactions and pay the base gas fee 10 times. This wastes their money and creates poor user experience. The insert items batch functions accepts a list of new strings, vec string, is in one single call. We use the efficient .extend method to proceed all items sequentially within that single transaction. The users pay the base fee, gas fee, just once, regardless of how many items they add. Loops are inherently expensive in the smart contract because the gas cost grows linearly. With the amount of data in your contract, this means the function gets lower and more expensive as your project grows. The getTotalItemCount batch functions demonstrate this failure. To get the total count, we loop over the entire items collection. As the contracts grow, this function becomes extremely expensive and will eventually run out of gas and fail. The getTotalItemCount optimized function solves that perfectly by simply returning self-item count. It's just illustration of the pattern, as Vec and other collections.learn method that is an internal counter. This automatically updates just like the item count, so there is no need to keep track of it separately in the specific case. This counter is updated once in the bench function and reads instantly. Reading self-item count is a single, super cheap read from storage, which is constant time operation because the gas cost doesn't depend on the number of items. This counter will always execute instantly. And this ultimate gas save rule: keep the hard work of the blockchain. The NEAR blockchain is for verifying, storing, securing, not for complex calculating like sorting, image processing, or running big models. Any kind of intensive task should be done on the user's computer or a server before they submit the transaction. Your smart contract should only be asked to check a simple fact or verifying a small pre-calculated value. For example, calculate the winner of a massive contest on a survey and only send the contract to the winner ID and the final result. This keeps your contract safe, fast, and most importantly, affordable to run. You can also use a solution like Outlayer for off-chain computation, which helps bridge this gap. You will find the links in the description. That's it. You have learned how to save gas by NEAR collections, batching, avoiding unnecessary loops, and pushing heavy computation off-chain. Subscribe and ring the bell. See you next time.